ring, ring. And that booty on that thought he made me spring and spring, spring. Then I took her to my pad, made her sing and sing, sing. First she asked me for a fling, now she cling it, cling, cling. And she's bossy, but she threw it. Oh, you hella saucy, did you stew it? Wonder what it cost me. I threw some shoes in, ice be on my body. I'm never bruising. Hey, yeah, 4 flights, 1 month. Bitch, I'm from the future. Catch this baby going beast mode. She hit me with the nudie, with the nail class. Run me triple stepping
Okay,
in my scooty. Suck your head, man.
so we are live. Let me check the quality. Yeah, it is decent. Let me lower the volume. Yeah. So guys, I'm a software engineer and I want to switch to AI engineer. And I have a knowledge of some part of AI engineering, but I want to explore more and be confident on the topics what I am not aware of. So, we'll be going one by one. For example, I have worked with MCPs and tools and agents. I have worked with RAG also. So we are going to also revise the RAG concept again, and we'll go one by one. We'll know things. We'll explore what things to be studied, and we'll also need your help on understanding things. Um, so we'll cover ML fundamental design, system designs, and we'll go one by one. Okay. So I've actually created this Versal application by Claude, and this is basically going to be helping me prepping for AI engineering. And uh, I have basically told it to basically rank on basis of what actually asked for in the AI interviews. So, for example, you can see I have already have filter of all priorities and all parts. So if I switch between any priorities, it will show me accordingly. But currently filter is correct, and we'll go one by one. So I'm going to narrate also. I'm going to study also with you guys. Um, so let's start. So this is RAG. Let me check how RAG works. Okay, again. RAG upgrades AI acting like an open book exam. First of all, let me open comment section if there is any person along with us. Although nobody is going to be there, this is just for my self motivation, so that I don't go around and use my phone and stuff. That's why I'm doing these things. Okay. It is not really like having a connection or networking with you guys, but it's more of a motivation for myself to study for at least 1 or 2 hours a day, so that it will be beneficiary for me. Okay, let's start. I was looking at RAG. You can turn on the music. Let me quality 3 lo-fi. RAG working cheat sheet. Let me see cheat sheet if there is. Ooh. So it is showing us the motivation of using RAG. Question is being asked, and so basically, what I know that RAG is used for enhancing the ability of LLM. So, for example, if LLM doesn't have latest knowledge of something, like if when LLM is built, it is built till the date the last it is released. Okay, uh, basically trained to the last day it has been released. But what about after the day it has been released, right? So for that we use RAG. Um Also, for example, we have a personal information, like not personal, if enterprise level information, which we like to actually access through our LLM agents. So for that we use RAG. That was my basic understanding. So in the first figure, it is showing us pre-trained LLM used. Let's see if the cursor is visible or not. Can I increase the size of my cursor? How do I increase? Setting accessibility and then adjust. Okay. Settings, accessibilities, and mouse and pointer. Yeah, now it is good. At least for learning. I can see some people are looking at us. You can comment where you guys from and what are you learning, and drop anything which you guys want me to learn on like being a AI engineer journey. So in here it is showing us we were pre-trained LLM used for questioning and answering. Generated answer may have maybe inaccurate LLM can suffer from hallucination. Relevant information be beyond the scope. Right, that's what we discussed. That we can have a relevant information that can be beyond LLM's training corpus. Right, LLM has no access to the latest information. True. So question generation must be able to. Okay, this is cheat sheet. We are directly jumping to cheat sheet. That's why it is a difficult way to learn. Let's understand here what we had created through our Claude. Let's learn topic embedding. It is part of RAG only. So an embedding is a fixed length of vector of floats that represent meaning of piece of text and produced by encoded model. The whole point of the text in similar. Okay. Together in this, I mentioned semantic goals, unit cleanness. So and okay, embeddings are basically made by an encoder. Example, a sentence transformer like mini-LM and OpenAI's text embedding. So this must be a model, LLM model, which is used for making an embedding, right? Yeah. Cost optimized default model for default dimension price around 0.02 per million token of the. Strain with construct is Let's search in again. What is embedding? What is embedding? Let's use ChatGPT for this. Explain RAG as a simple person switching from software engineering to AI engineering. I want it to be detailed. Also want it to have example so that we can understand real for example too. Oh no. Everybody has no idea, even if you fine tune every company document changes up every week. So instead of teaching the model everything, we retrieve the relevant document first, okay? Then we send those documents to LLM. That's literally RAG, okay? Retrieval augmented generation, correct? The model doesn't magically know the answer, right? It reads through a relevant document just before answering, okay? So think like a software engineer. Imagine you are building Stack Overflow, and the normal search will be user goes to search SQL and it searches to database and it returns the rows. A RAG is also almost identical, and here user searches a question, it converts into vector. That vector searches through the vector database and it retrieves the similar documents. Yeah, I remember something. I'll use Epic Pen also for this. Okay, retrieve similar documents and those docs to GPT. Uh, GPT generate answers. Okay. Notice something. GPT isn't searching. Your application is searching. Okay. GPT is just answering based on what you give. So. Example, suppose you have a company with this document, employee handbook, leave policy, employee receive 20 paid leaves, 10 sick leaves, carry forward allowed. Okay. So if user asks how many sick leaves do employees get, it without RAG, it doesn't know. Correct. GPT doesn't know. With RAG, application goes through search documenting and then it finds privacy policy, gives document to GPT. GPT retrieve 10 sick leaves. Okay, it simply reads the document. Okay. How does it have document? Let's see if it discusses here. Why can't we just send every document, right? If your company has 50,000 PDF, then it means it must be having a 500 GB of data too. GPT cannot read everything. Context windows are limited. True, context windows are limited. GPT can only take in some amount of data, right? It can't take whole 50 GB of data. And even if it takes such high amount of data, not in 2026, if it happens like logic, possibly if it happens, then also it is too tough to like too resource consuming to basically work upon, right? And usually this will not going to happen because it is very resource heavy and this is not a correct way to do it. This search is not keyword search. Okay, true. Okay, normal search, it will do vacation policy, document, leave rules. Keyword search, no result. Okay, true. Vacation is not equal to leave. True. AI search work differently. It understands the meaning. Vacation, leave, holiday, time off. This becomes similar. Okay, true. So basically, the whole thing. For example, the vector. There's a vector, and this whole thing, leave, holiday, time off, are actually nearby the vector, right? This becomes similar. There is where embedding comes. Embedding converts text into number. So I love dogs is basically having a vector position. Okay, this is position, right? Embedding converts into text into number. This number must be like a position. Another sentence is like I like puppies, which is actually very close, should be closer to the I like dogs. These right, this vector are very close because they mean similar things. True. How to cook pasta? must be very far away from I love dogs and I love puppies. For example, uh, is a graph. Uh, for example, I love puppy must be placed here and I love dog must be placed somewhere here. So I like pasta is should be very far here or somewhere. I don't know the place it should be, but it should not be close to here, right? Because we are talking about liking an animal here, and here it's talking about food. Should be closer, but not closer, right? Let's see how it has discussed here. Far away, true. That's what I thought. Think of embedding like a GPS coordinate. Every sentence gets a location. Okay, so this was uh, like a location thingy. What it is showing us here. Let me check the comment section if there is any person watching us. Absolutely nobody. Hmm. Very nice. Nobody is there. That's okay. This form is nice. Okay, so yeah, same way it is showing here. In the graph, dogs and puppy are very close, and cat is also close. Is this a graph or I'm just drawing shit here? Okay, there is a separator or something, and finance, stock, taxes are different, like far away from dogs and puppies and cats. In normal databases, ID, name, salary, okay. Okay, in vector databases, it is ID, embedding, and document. Okay. So does that mean embeddings means locations or what it is? I understand that embedding does convert text into numbers. Okay, let's read now. ID, embedding and document. Okay. Okay. So example doc1 is ID. No. Okay, example first documentation, leave policy, embedding, stored inside Pinecone, and this is basically vector databases, software, Pinecone, yeah, vector database to build knowledgeable AI. So it is a database, a vector database. So I think Pinecone and Chroma, these are the popular one. Okay. Let's build it mentally. There is a PDF form, there is a HR PDF form, there is a holiday PDF form, there is a salary PDF form. Hi brother, how you doing? Doing good, bro. How are you? Where are you from? Uncle ek bar ek. What's up, brother? How are you? Where are you from? Tell me. Okay. The first step is taking a document, and second step is splitting the document instead of storing. Okay. So instead of storing 200 pages, which is combination of all this PDF, it splits into chunks. So will it split into 4 chunks or how many chunks? is it dependent on the number of pages or content of the pages? Let's see. Because of GPT works better with smaller pieces. So will the chunk will be like of 2 words or a whole sentence? It is not described here, but let's go through next what it has been said. Doing good, bro. Right now from UAE, I made own AI model. You know, the great to see people trying out AI. Thank you, bro. What AI model you made? How many billion parameters? How did you do it? What things should I learn, man? I am a software engineer. I have done like development on full stack, like one stack development. I do. I've also used like I know how to use like AI endpoints and using AI for like doing agentic work, but I want to go deeper. Like implementation part I have done, but I want to know the core part of AI things. So like do comment, do help me out. How do I start? How do I go to it, right? If I am going on confusing myself, please correct me in the comment section if you are there. From UAE. So you are citizen of UAE, or like you are like you have a visa and you okay, I see. Step 3, create embeddings. Each chunk goes to embedding, chunk, embedding, then embedding gets stored. The storing part must be saved in a vector database like Pinecone. Okay. User asks how many sick leaves. It convert question to embedding. If got email or anything, I'll be glad to help you out. And okay, I'll drop you my email address in here only. Let me go to YouTube. I'll be glad to help you out, and this is my email address. So step 4, user asks how many sick leaves. It converts and okay. This we had gone through. Step 5, search. Question embedding. Okay. Find the nearest neighbor. How many neighbors? Okay. It goes to chunk 2 from GPT instead of question. Now we send a context. An employee receives 10 sick leaves. Employee received 10. Okay. Noted. I'll try to give tips on other advices later. Good luck, brother. AI isn't easy, but you got this. Okay, bro. Thank you. Like I always think that thing I'm learning is not above me, and I should not complicate things, and like I should be confident in learning things. So I'm not going to give up, bro. Thank you, though. Thank you for your comment. But do share any content you have, any resources you want me to learn, right? Also do like the stream. So what is actually happening? This is a prompt ChatGPT gives. You are an HR assistant. Context it gives. Carry forward aloud question how many. Answer only from the context. That's all. No magic. Okay. In real Python example, let's see. So it install LangChain, ChromaDB, and OpenAI. Three things. This DB will be used for vector database, and OpenAI will be used for basically GPT, and LangChain will be used for RAG. Okay. Employees receive 20 paid leaves, 10 sick leaves. Carry forward allowed. Okay. Suppose we have this. Okay. Suppose we have this text file, and this text file is containing just this content. Okay. So for creating a embedding, this is the code. We are importing LangChain OpenAI for OpenAI embedding. This is this library we are using because we are going to use that text embedding model we saw earlier, right? Took the text from policy.text, and which coding language you want to use for AI, Python or what? Python it will be. I don't think so. Like in Express, Express server, we do use, but we mostly use in Python. So definitely going to use Python. I'm more versed with Node.js, but I don't have a problem to switching to Python. At this 2026, I don't think so that should be a problem to anybody to switching to any language. Because after all, we have to think about the system design and stuff, and taking things problem solving, not really focusing on the language. Language will be decided on the project or work we are doing. Okay, so splitter will take. So like my question was how much the size will be or chunking. So here it has taken 100, and this chunk overlap. Like chunk overlap, I understand that. For example, this is the one chunk, and this is second chunk, but there should be overlapping. So for example, here to here is one chunk, and second chunk will be starting from, for example, here. So there should be a overlap for familiarity, I guess. Or let's see. Need to understand more, but this is what I have understanding right now. Chunk equal to splitter or split text. To pass the text as a parameter. Takes embedding from OpenAI embedding function. Chroma dot from text chunks embedding. Okay, so now vector database contains the embedding. Okay, this is how we store the embedding. Okay, now for searching, db.similarity search. How many sick leaves? K equal to 2. This K, I remember this K is basically. Let me check what was that. What was the K? So K is basically things we are searching, but the limit of the things we are searching, the familiar things we are searching, right? I don't know the right terminology, but I think this is what K is. Right, and then it prints the result. The output will be employee differently, this and that. Now ask ChatGPT. page content. Let me see the chats. There is no chats. Now ask GPT. So it takes the page context as a context here, and then it prompts answer only using from this context, the context it passed here, and how many sick leaves. So basically, it takes the model and the prompt and prints out the output. So how LangChain make this easier? Okay, let's see this. Instead of writing the retrieval and prompting manually, LangChain provides ready-made components. Okay. So this part, right? This fetching the context and prompting part is what LangChain makes it easier. Instead of writing retrieval and prompting manually, the LangChain provide ready-made components from LangChain.chain imports from LangChain OpenAI import chat OpenAI. So we are taking LLM as a model here. QA equal to retrieval QA from okay. And row query pass and it prints out the result. Okay, let's see what it does. From the chain type. Question creates embedding. That's the trauma. So when question is asked, then it creates embedding, or it creates embedding one time after any new context has been provided. So internally, LangChain performs these steps: create embedding, search chroma, retrieve relevant chunks, build prompt with context. True. Okay. Real world architecture will be like uploading a PDF, document loader, some right. There will be file reader in like Python or whatever. Then there will be a text editor. Then there will be OpenAI embedding, which will basically take chunks and overlap chunk also, and it will store into vector database like Pinecone. And when user asks the question, it creates a question embedding. So okay, it creates a question embedding, and it basically search like okay. Let me draw things and learn. For example, my answer is here, and when it creates a question embedding, my question, for example, gets stated here, and then it finds a similar things from the whole graph, and it retrieves top k. Top k means, for example, there are two things near me, and it finds two embedding stored here, and it basically takes those document chunks and give it to GPT, and GPT then have a lesser context and a correct context, and then it can basically generate. Okay. So this is what a real RAG, real world RAG look like? Okay, as understood. Perfect. So we have learned RAG now. Let me also open my email. Let's see if anybody has sent me a mail with the resources. Not right now. Nobody has sent anything. That's okay, man. So one topic is clear. MCP tools and agent I know. So in MCP, let me narrate this how MCP works. There is a MCP server and there is a MCP client. Server and there is a client. Client will be like Claude, right? Here I have Claude here. So server basically provides some tools. Tools are basically functions, and those tools have basically those tools takes parameters and has some context to it. For example, how do I explain? Let's take a real world example. For example, we know Canva. Canva is basically used for creating an image or something, right? So for that, Canva can create a server where like there is a create image tool. So here basically first of all we have to make a connection. Let's say we have a connection through a bearer token or something like our server provide. So for example in Claude we have to add for example you are working in Claude CLI, so in your command prompt you have to add Claude add whatever your MCP client server name is, then the whole your creds. Okay, so I don't want to go into the connection part because the connection part is easy and actually it is shown in the server how to connect your client with it. So let's understand what is tool. For example, in the case of Canva, there could be a tool called as create image. So that will take basically some parameters. For example, a prompt, and then it will take the dimension, some basic instruction maybe. It will take all this from the client to this function, and this will return output of it. This is, think of it as a REST API, but REST API doesn't have the context. Client now knows what that function is used for, and there are basic resources around it for explaining the environment, how the whole Canva works and stuff like that. This is one example which I have given you of the Canva. Otherwise, there could be a real world example also. So here it has also been shown a client is your hosted app, then it calls to MCP tools and AI gets hand. Okay. So this client Claude desktop is basically host of it. Client maintains one-on-one server connection, exposes capability use over JSON RPC. Okay, these are the studio transport stdio IO. Okay, the server and local subprocess. I can see some guys here in the chat. Do comment where you guys from, what are you doing, what are you learning. That okay. Now I can't see anything. What happened, bro? Okay, the transport can be STDIOs, low latency idle for local file system. This, for example, of Canva, this won't be used. The streamable HTTP will be used. Change the new song. Tool calling mechanism. Give me a second, guys. Somebody is at the doorstep. Yeah, I'm back. Okay. So we are 42 minutes in. Okay, that's good. That's good. The tool calling mechanism, a real depth probe. The model does not execute anything. You pass it to the tool schema. You pass it to the tool schema, name, description, JSON, schema parameters given, a query, model, limits, structure, tool request. Naming a tool, its argument, your runtime. Okay. Agent failure modes. Internet loops. That's okay. Let's go to ML fundamentals. Okay, what is regression and what is linear regression? I want to know this. As I said, I want to go to in depth, not just implementation AI. I want to know the core of AI. So here we were actually like talking about implementation part, not the core, but I should be knowing the core before, or not before, but it should be a prerequisite to understand it. Like there could be question asked to me, what is regression AI, and if I go blanked out, then it has no meaning of me being a AI engineer. Okay. What is regression? Linear regression predicts a continuous value weighted sum of the feature. Okay. Plus bias intersector. Okay. Let me search through linear regression. How does it look? So there is a graph, and this dot point is basically the markers, and it is like it is going linearly, and okay, the simple statistical method and machine learning algorithm to predict outcomes. Okay, this is used for prediction. So for example, what you think the next data point will be? It will be somewhere around here, and then it will go diagonally, like as we expect. Okay. Core concept is in independent variable x, the input or the cause. Hmm. X is the input or cause. Hmm. The output of the result you want to predict. Okay. Y equal to mx plus b, the math formula for the straight line. Okay. Simple model for predicting continuous values. It finds a relation between the input, feature, and output. It is used in forecasting and predicting the salaries based on experience. Okay. How does linear regression work? It finds the best fitting line by minimizing the prediction errors. Least square method. Okay. Best fitting lines by minimizing the prediction errors. It calculates the coefficient of the variables that minimizes the error prediction. Okay. It calculates the coefficient of variables, minimizing the error in the prediction. Okay. This is going trust. Types of linear regression. The simple linear regression predicts the dependent variable using the single independent variable. Okay. Uses two or more independent variable to predict the dependent variable. Oh, understood, bro. Let's learn more. For example, suppose we want to predict a student exam score based on the number of hours it studied. As the study hour increases, the exam score generally increases as well. Independent variable, okay. Okay. So, okay. So basically, okay, understood. So independent variable decide the dependent variable. So how the input will be, that's uh, the output will be dependent on the input. For example, to decide when I'll shave my beard, uh, for that it needs a date where I had shaved last time, right? So basically, one can basically measure how much days it takes for me to shave my beard and stuff like that. Okay, this is one of the analogy I thought right now. The linear regression uses the independent variable to predict. To predict the dependent variable through. Okay. Best fit line in the linear regression, the best underlying state line. The best represents the relationship between the independent variable and the dependent variable output. The goal is to minimize the difference between the actual data point and the predicted value generated from the model. Number one, the goal of the best fit line. The goal of the linear regression is to find the straight line that minimizes error. This line happens to predict. Okay, I've read it so many times that this line is helping us to predict the dependent variable. Okay, for new unseen data. This y is called as dependent. Okay, and x is independent. Y equal to mx plus b. What is m and what is b? Let's see. Theta 1 represent the intercept. Okay, this one, this theta 1, and which is the value of y when x is 0. When x is 0, the value of y, this. Okay, like it is shown here in the intercept. Okay, theta 2 represent the slope, which shows how y changes for the unit x. That slope, which shows how much y changes for unit and change x. Okay. There are many types of functional modules that can be used for regression. A linear function is the simplest type of function. Here's y. Here's x may be single. X meaning independent variable may be the single feature or multiple feature representing the problem. For example, for simple linear regression with one independent variable, the best fit line is represented by the equation y equal to mx plus b. Y is predicted value understood, independent variable, m is slope of the line diagonally which is going, b is the intercept, the value of the y when x is 0. Okay. What are we doing here? Assumption of linear regression. This is linear, this is non-linear, and this is also non-linear. Okay. Homoscedasticity, heteroscedasticity. Okay. Let's see the implementation. Boarding NumPy, Matplotlib, sklearn linear model. It is importing linear model. Okay. Class np.read, basically np is NumPy, np.random.seed. Okay. Okay. And the brand 50 to 1 into 10 and 100. Okay. Setting a training. Okay. Visualizing. Okay, just for visualizing. Okay. Okay. Let's see the next thing, logistic regression. Logistic regression is a supervised machine learning algorithm used for binary classification. Let's see the difference between the linear and logistic. What is logistic regression in machine? Logistic is a supervised machine learning algorithm used for classification problems. Unlike linear regression, which predicts the continuous values. Okay, right. It will produce dependent variables. What you say, position or the value it will come. Okay, to predict the probability that input belongs to a specific class. It is used for binary classification where the output can be one of the two possible categories, yes or no. Okay, right. True or false, 0 or 1. It uses sigmoid function to convert. Okay. Let me pause this. Predicts the category. Okay. Uses sigmoid as to solve the classification problem. So this regression is used for classifying one or two things, right? Types of logistic regression: binomial, multinomial, and ordinal. Two classes. Binomial meaning two classes, 0 or 1, true or false. Okay. Multinomial, it can be more than two unordered classes. Unordered. Okay. So More than two unordered classes. Okay, that dog shit. More than two ordered classes, low, medium, high. Okay. I'm learning. What is logistic regression? Um, okay. It predicts the probability of binary outcome. Okay. 0, 1, yes or no. It uses sigmoid function to map the inputs and probabilities. 0 or 1. Ideal for classification task. Okay. Let's see what we see more here. Binomial logician used. This we understood. Used for dependent variable has three or more categories with a natural order. Okay, low, medium, high, dependent ranking category group. Okay, this we understood. And later in the assumption part, in independent observation, each data point should be independent of the other, meaning there should be no dependence between observation. Binary dependent variable, the target variable is typically binary and can take only two values such as 0, 1, yes or no, or multi-class problem such extensions such as software-based logistic regression are used. Linearity of log odd. The independent variable should have linear relationship with log odds of the dependent variable. No extreme outliers. The extreme outlier can distort coefficient estimates the negativity and affect the model performance. The large sample size, a sufficiently large data set help produce more reliable and stable predictions. Okay. Understanding the sigmoid function. The sigmoid function is a key. I want to go deeper, like mathematically. Just want to know for the basics of ML. Let's see what it does. For this, we are taking in some test and split accuracy score. And we are printing. Okay. This is an example of implementing multinomial of an unordered one, right? Score is 96.66. What iteration is 10,000? Random state is 0. Extrain white line. Extrain this white line. Okay. True positive, true negatives up upon total. Okay. The difference between linear and logistic regression. This we understood. What type of problem knowledge classification? Correct. What activation function? That is also correct. What is output of logistic? Oh, I guess this, right? Which of the logistic regression is used for ordered categories? Ordered one, right? Ordered was multi-ordered, ordinal. Accuracy and then. Okay. Then let's hop into next topic, loss function. MSC, mean squared error for regression, cross entropy for classification. Training minimizes the loss versus gradient risk. Let's search for loss function. A mathematical formula used for machine learning to measure how far off the model prediction are from the actual and ground truth. Okay. That is an important topic then. Activation function, loss function. Let's learn all this thing, I guess. Unlocking the neural network performance through the lens of the function and curves. Why this concept? Neural networks have revolutionized machine learning across the countless domains, but the effectiveness depends on heavily on the underlying mathematical function that powers them. The comprehensive guide enforces the three fundamental components that determine the model performance: activation functions, loss function, and the learning curves. By understanding these elements, the AI practitioner can significantly improve their ability to design, train, and optimize the neural networks for the real-world applications. Why this concept matters in deep learning? In deep learning, the choice of the function and their interaction create the foundation of the model capacity to learn patterns from the data. Each component serves distinct purpose. Activation per function transform linear inputs into non-linear outputs. Okay, enabling network to approximate the complex function and the pattern. Loss function is basically quantifying the difference between prediction and the ground truth, providing the optimization. Basically, how far is like how wrong it is. Learning curve visualize the training progress over time, revealing the patterns and diagnosis model issues. ReLU, rectified linear unit. ReLU function has become the default choice for many deep learning architectures due to its simplicity and effectiveness. It outputs input directly if positive, otherwise it's output 0. Okay. Computationally effective, simple max operation helps mitigate vanishing gradient problem, promotes sparsity in activation. The dying ReLU problem is basically neurons can become permanently inactive when receiving constantly negative inputs. Okay. Not zero centered, which may be convergence, which may slow the convergence. Leaky ReLU. Okay. It's too much. As I said, I want to go deeper in core topics, but I have to go deeper with the videos, not like text wise, because I won't understand the things here. Okay, this is good for revising things, but I don't think so this will work for me now. What is bias variable? Let's stick to the implementation today then. We'll stream till 1 more hour, like till 10 o'clock. So let's go. System design, open-ended design, and AI feature reason with constraint. Okay. They hand you blank a page, build an AI feature. They watch how you balance speed, cost, right? Not the file and answer. Okay. Repeatable structure for any design and AI feature. Clarify scale documentation, QPS. What is QPS? Quality performance something. Queries per second. Okay, understood. How much query per second will be for example, the website. For example, the endpoint, not the website. Scale, okay. Latency budget, cost ceiling, how much the limit should be, accuracy should be, freshness needed, okay. In addition, the load, The chunking and embedding, the storing in the vector. Okay. Query part. Embed query. Hybrid, retrieve, re-rank, assemble, prompt, generate, site. Eval, the golden set of CI. Retrieval and generation metrics. Plus production monitoring. Non-functional latency costs. Just give me a second, guys. Okay, I'm back. So, non-functional will be latency, cost, reliability, security will. Okay. The levers they are drilling, they will drill, not drilling. Latency, P95 too high. The stream tokens to front-end via SSE for perceived speed scan. Oh my god. Okay. I can see some guys. Guys, comment down below where are you from, what are you doing, what are you learning. So guys, I have created this documentation to learn one by one the topics of AI engineering, and we actually learned RAG and MCP tool, and we did go through the some part of ML fundamentals. Then we are currently in system design of it. So currently we are understanding how like we have to design when our managers or the superior ask for us to design a AI system. So we are in the current we are in this topic, the levers the managers will drill on. So this is okay. Stream tokens to front-end via SSE, cache embedding, semantic cache for repeated queries, response functions, and use it to smaller, faster, where the quality allows. So cost will be 40,000 a month. Model routing and cascading. Try cheap model first. Escalate the big model only when needed. It's smaller embedding. Cache aggressively. Trim. Retrieve context batch wherever the possibility. Reliability, timeout, retries, exponential backoffs, provider fallback, and it should handle gracefully. It couldn't answer that. Okay. Path should be LLM API will fail and rate limit. Okay, right. Freshness, keep the index in sync with the source data by incremental updates, change the data capture, not full re-indexes. Okay. Version, I can see guys in comments. So do comment whatever you are doing, or whatever you are learning. Where are you from? How's life? All good. If any advice you guys have for me, then do comment in the comment section. Also do like the video, not the comment section. Okay. These are basically levers managers will drill on to basically on the latency, cost, reliability, and freshness of the agents we are building, the system we are building. Okay. Transformer. By the way, this is a document where I have created for basically preparing for AI engineering role, and here I have set the filters like for example must know, high plus. So if I click on this must know, then those topic will appear that is a necessity for like giving a AI engineer uh, interview. Okay, so we are in all parts, so we want to learn all the parts of the AI engineering. Currently we are in system design part. This is just an overview, but we'll go deeper in the next stream. I want to switch to next stage. This is a transformer. Transformer architecture internals. Explain the machine attention math, ROPE, MOE, flash attention. What's inside the AI brain? How word looks at every other word to word out the meaning. Okay. So frequency is 4 out of 5, meaning this question is being asked in interviews, and use of this basically topic is 2. So use of this thing is less. And what is difficulty? The difficulty is high, so this is a difficult topic we are diving in, and priority is 4. So it is kind of priority thing we should know. So it has given high. Okay. Transformer architecture internals. I think we have to search through internet to understand these topics. Right. Let's search. LLM transformer visually explained. Then we'll learn inference and serving optimization, making AI answer faster and cheaper, batch the request, reuse work, and clever tricks you never pay for idle time. Okay. This is right topic. In plain English, this advanced agent orchestration, the smarter agent, one that plans ahead, remember the past, and learn from the mistake, and sometimes team up. Okay. I don't want to read others. It is exciting, but I should go to the transformer explanation. So what is transformer? Transformer is a neural network architecture that has been fundamentally changed approach to artificial intelligence. The transformer was first introduced by seminal paper. Attention is on. Okay, this is what the paper AI guys talk about, that this paper changes the whole AI wave. Abstract. To get access, I have to click on something, but let's see the abstract. The dominant sequence transformer. Okay, I didn't understand. Let's dive in to what you were saying before. Okay. In 2017 and has become go-to architecture for deep learning models, powering the text generative models like GPT, MetaLlama, and Google's Gemini Beyond Text. Beyond text, transformers is also applied in audio generation, image recognition, protein structure prediction, okay, like bioengineering, and even game playing, okay, like AI bosses and stuff. AI bosses, AI enemies, demonstrating its versatility across the numerous domains, okay. The fundamentally the text generative transformer model. The text generative transformer models operate on the principle of next token prediction. Okay, right. Given a text prompt from the user, what is most probably probable what is the most probable oh my god, what is the most probable next token, a word or a part of word that will follow the input? Okay, for example we are writing a sentence and we get a intelligent what you say intelligent hint when we write in, for example, Claude or Cursor, right? That can be example of next token prediction. The core innovation of the power of transformer lie in their use of self-attention or mechanism, which allows them to process entire sequence and capture long-range dependencies more effectively than previous architecture. GPT-2 family of model are prominent example of text generative transformer. The transformer explainer powered by GPT-2. Okay, what is a transformer? Embedding. Every text generative transformer consists of these three components: embedding, transformer block, output probabilities. The text input divided into smaller, what we discussed in RAG part, right? So it is like divided into smaller units, and it is called as tokens, which can be words or subwords. Like it can be a word, not word, but words or part of those words. Like for example, here to here is a token. These tokens are converted into numerical vector called as embedding. Okay, now understood what is embedding is. So that the basically that array was containing some numbers, right? Must be containing like xy axis location of it. The, that numerical vector is basically called as embedding, right? The which capture the semantic meaning of words. Okay, semantic meaning. Like what? Okay, connected meaning, like the similarity of words. Okay. Transformer block is fundamental building block of the model that processes